Hello and welcome to this art tutorial and welcome to part 9, dimensionality reduction. So we are starting this part with our first technique of dimensionality reduction, which is PCA, principal component analysis. And so in dimensionality reduction there are two techniques, feature selection and feature extraction. We did feature selection in part 2 when we implemented the backward elimination model to select the most relevant features of our matrix of features, that is, the features that explain the most the dependent variable, and now we are starting this new technique of dimensionality reduction, which is feature extraction. And PCA, principal component analysis, is one feature extraction technique. So as a reminder, let's say your matrix of features has m independent variables. Well, what PCA will do is that it will extract a smaller number of your independent variables, but that are going to be new independent variables, like new dimensions. And these new independent variables extracted are going to be some new independent variables that explain the most the variance of your dataset. And that is regardless of your dependent variable. And that makes PCA an unsupervised model, in the sense that we don't consider the dependent variable in the model. So that's PCA, and remember in part 2 and part 3 we worked with one or two independent variables. Well, that was for two specific purposes. The first purpose is that we needed a graphic visualization of our results, and since each independent variable corresponded to one dimension in the plot, well, we could visualize our results with at most two independent variables. And the second reason is that thanks to this PCA dimensionality reduction technique, well, even if we have a lot of independent variables at the beginning, well, we can end up with much less independent variables, but that are going to be relevant independent variables, because these independent variables will explain the variance of your dataset. And therefore, since we can reduce this number of independent variables, well, we can end up with 2 or 3 independent variables and therefore visualize the results as we did in part 3. And this is exactly what we're going to do in this tutorial and the following tutorials of this section and the following sections when we cover other dimensionality reduction techniques like LDA and also kernel PCA. Well, we will have many features at the beginning and therefore it will be impossible to visualize the results. But then when we apply PCA or LDA, we will reduce the number of features down to 2 and therefore we'll be able to visualize the results. So let's start right now, and let's start by setting the right folder as working directory. So as usual, we go to our machine learning A to Z folder, then part 9 dimensionality reduction, and here we are in the first section of this part 9, principal component analysis. That's our first technique. Let's click on it, and that's the folder we want to set as working directory. Make sure that you have the wine.csv file, and if that's the case, you're ready to click on this more button here to set this folder as working directory. Perfect. And now we're going to open another file that we made in part 3 classification, which is our logistic regression.r file. Because what we're going to do is take this logistic regression code, then we are going to change the name of the dataset because we will be working on a new dataset, which will be the wine.csv file, and we will apply PCA on this dataset. And of course, I will explain quickly the business problem behind it. So I'm going to take everything from here down to the bottom. Here we go, copy, and I'm going to paste that in my pca.r file this way. So let's go up and let's change the name of the dataset. This is not social network at CSV. This is now wine.csv. That's perfect. So now what we're going to do is first import this dataset and then apply data preprocessing. Maybe we'll need to change some things like the indexes here, but this will be very quick. So first, let's import the dataset. So I'm going to select this line and execute. Here we go. The dataset is well imported. Here it is. And now let's explain the business problem behind it. Okay, so first of all, this is a very famous dataset, well known in the machine learning literature, and that you can find on the UCI machine learning repository, as you can see here, and you can find this page at this link. So basically, first, what are the independent variables and what is the dependent variable? Well, the independent variables are all the variables from this one, alcohol, up to this one, proline, and this last variable, customer segment, is the dependent variable. So in the original dataset, this dependent variable is not called customer segment. This is actually the origin of the wine. But let's imagine that we, as data scientists, are working for a wine business owner, and this wine business owner gathered all these informations in this dataset. And so first, what this business owner did is that it gathered all the informations of these independent variables here, that are chemicals informations of several wines, and this business owner applied some clustering technique to find some segments of customers that like a specific wine depending on the informations of the wine. And by applying these clustering techniques, this business owner identified 3 segments of customers. That's the first one here. Then we have the second one, and eventually the third one. So based on these informations and thanks to its clustering techniques, well, this wine business owner managed to find some segments of customers, each segment having a specific preference for a specific wine. So basically this business owner found 3 types of wines, each type of wine corresponding to 1 segment of customers, and therefore 3 segments of customers. And why does it create added value for his business? Well, that's because now what this business owner can do is take all these informations of the wines as well as the information about the customer segments and make a classification model like logistic regression in which the independent variables are all these variables and the dependent variable is the customer segment. And therefore for each new wine, it can predict to which customer segment it should recommend this wine. So that adds a lot of value for this business owner. But then, if this business owner wants to have a clear visual look at the prediction regions and the prediction boundary of the classification model that we're going to build, to be able to see if the predictions are in the right spot of the customer segment, well, it cannot be done with all these independent variables. Because of course, we cannot represent these many independent variables in one plot. That's impossible. So what we need to do is apply some dimensionality reduction techniques to extract 2 independent variables that explain the most the variance, and then we'll be able to see the prediction regions and the prediction boundary. And therefore we will clearly be able to see where the customer segments are and where these predictions of the customer segments are according to the extracted features of all the informations of our independent variables. And remember, these extracted features are called the principal components. Alright, so now that we understand the challenge and the business problem, let's apply PCA to see how we can reduce the dimensionality of this dataset, because indeed it contains 13 dimensions, because it contains 13 independent variables, and we'll see how we can use PCA to reduce this number of independent variables down to 2 independent variables. But be careful, it's important to understand that the new 2 independent variables that we'll have in the end are going to be new ones, as opposed to feature selection, where we end up with 2 independent variables that are among these original 13 independent variables. Here with PCA we'll get new extracted one, and that's the important distinction to make between feature selection and feature extraction. Alright, so before we apply PCA, as usual, we need to pre-process the data, and this is actually going to be very quick because our template is ready. We will just need to change just a few things. So first, dataset equals dataset 3.5. That's just to select the independent variables that matter for our problem. But here everything matters. We just want to reduce the dimensionality of this dataset. So we will keep all our independent variables here, and therefore we don't need this line here. So I will just remove it. Okay, so first section, importing the dataset ready, well executed. Now let's move on to the next section. So the next section is about splitting the datasets into the training set and the test set. And here, be careful, we just need to change this name of the dependent variable, because in logistic regression we were dealing with the social network ads CSV file and the dependent variable was purchased. But now for our new business problem, the dependent variable is not called purchased, it is called customer segment. So we just need to replace purchased here by customer segment. Here we go. All right, do we keep a split ratio of 75%? Well, let's rather take 80%, but that's as you want. It's just that 80% is a good split ratio to take, so we will go with that. And then here for training set and test set, we don't need to change anything. So we are ready to split our data set into the training set and the test set. So let's do it. I'm going to select all these sections here and press Command plus Enter to execute. Here we go. The training set is now created as well as the test set. Great. So ready to move on to the next section. The next section is about feature scaling. And for PCA, it is way better to apply feature scaling. You can actually apply it by playing with the parameters of the PCA function that we're going to use afterwards. But let's take this feature scaling part of our code template to put our features on the same scale. So here we just need to change the indexes. We actually need to specify the indexes of the features we want to scale. So basically the features we want to scale are all the features from alcohol to proline. And so what we can do is specify that we want to scale all the variables except the last one, customer segment, that has index 14. So therefore, here, instead of putting the indexes of the features, we can replace it by -14. We can remove that. Let's copy this because we will do the same for the others. So let's replace that here by -14 and -14 here as well, and eventually -14. All right, so now the feature scaling part is ready. So we are ready to select this section and press Command or Control plus Enter to execute. And now all our variables are scaled. As you can see, we can clearly see that all our features are on the same scale. And of course, the customer segments kept its labels 1, 2, and 3. And same for the test set. Let's make sure of that. All right, perfect. So feature scaling done, and actually the pre-processing phase is completed. So we did that quite efficiently, but that's good because now we're getting to the exciting part, applying PCA to our data. So actually we will do that right here. You apply PCA right after the data pre-processing phase and just before you fit your logistic regression model to the training set, because of course you want to train your model on your new data set with the new extracted features, that is with the 2 new extracted features that will explain the most the variance. And after you trained your classifier, you're ready to predict the test set results, make the confusion matrix. Then you can also visualize the training set results. Remember, this section is applied on a data set that contains 2 features. And so we will see what we get by extracting these 2 new features. All right, so to finish this tutorial, I'm just going to introduce this new section here that I'm going to call applying PCA. All right, and in the next tutorial, we're going to apply PCA, and then eventually we will build our model on our new reduced dataset. So I look forward to doing that in the next tutorial, and until